Hello everyone. I hope all of you are keeping safe. Thank you for having me here today. I'm Pavanimani. I'm from Huntsville, Alabama. I currently manage iTwin services development for Bentley Systems. I've been with Bentley for about 20 years and I've worked on various product lines for Bentley. We're a leading global provider for software solutions for the infrastructure industry. We provide BIM applications, engineering and simulation applications, as well as digital twin cloud services. Today, we're going to talk about digital enablement with the integrated engineering workflows to establish feedback loops using digital twins for better outcomes, continuous feedback for continuous and consistent improvements to your physical asset over time. Now, what is a digital twin? At a very rudimentary level, it's basically a replica of your physical asset in the real world as digital information that has been brought together for you to use in conjunction with the physical asset. Usually, you keep this digital information up to date as you operate your physical asset, and this lets you derive better insights and performance out of your physical asset over time. Now, why digital twins? As many of you operate these physical assets in the real world, especially for the complex ones, you have many disciplines and teams, maybe even globally, operating and influencing what is happening and how you're working with your physical asset over time. And this generates a lot of information. It generates a lot of engineering information in the form of BIM models, maybe just drawings, specifications, geotechnical information sometimes. You also have operations information, like flying drones to capture real-time information around the facility, or you have sensor information from your IoT devices that are there. You're also collecting information in the form of LiDAR scans, your point clouds you're generating. You also have information as you're operating your physical asset in the real world, like tracking your components and equipment with tags. You're doing maintenance and issuing work orders to fix or change things, and you're also inspecting things. A lot of this is information you're collecting together. When you bring all of this cohesively together, you then have a digital twin. And this then lets you understand what's happening to your physical asset in a way that is better than just looking at the physical asset. In addition to that, you're able to get better performance out of this. And as you continuously keep this digital twin updated with what's happening to your physical asset in the real world, you're able to get better outcomes through, whether it's through just visualization in your browser on your device or through immersive visualization with devices like HoloLens. You're able to visualize the 4D timeline of change on your physical asset. In addition to this, the advantage of this cohesive information is that you're able to run machine learning algorithms on this data and gain better insights. That is a compelling proposition. As we assemble our digital twin, you can look through the workflows that this information is going to go through. Thinking of greenfield projects, your information can start from the conceptual planning stage, go through the design, design phase, then through construction, operations, and maybe even end of life. And as you're taking this, we tend to think that maybe this technique of using digital twin technologies is only useful in greenfield projects, but that's not really the case. You can get started wherever you're in your workflow of your physical asset. If you're starting construction, or if you're in the operations or maintenance phase, you take the information you have today to get started through this digital twin journey, and you can improve on it over time. Now, we talked about all the information that comprises the digital twins. Let's look at it through the lens of all the specific information you could potentially collect. You have all of these digital assets in the form of 2D, 3D, 4D, even 5D information that you can collect together. You could have reality data that's captured through drones or LiDAR scans. You have your subsurface information. You have your terrain information and GIS information. And you can treat all of this information as layers. And when you bring together all of these layers of information, then you can think of this as a comprehensive set of information that you can build over time. So if you're missing one or two layers today, it still doesn't stop you from gaining all the benefits of using digital twin technologies today. You just add more information over time, and the more you benefit from it as you go through this journey. And now that we have established the digital twin information, let's talk about the feedback loops you can establish with the physical asset. Your physical asset is going through change all the time. Broadly speaking, these are three kinds of change. There's the observed change because of entropy that's happening with the physical asset or around the physical asset. Then there is the business or plan change. You're repairing or maintaining equipment. You're adding new structures to your facility. In addition to that, there is the more complex engineering change. This engineering information change usually brings with it, workflows like editing, merging, reviewing and approving information that's going through. And you're going to do this many times over the life cycle of your physical asset. And that's managing complex change over a long time of the life cycle of the physical asset. Now, as you apply the digital twin technologies to all of this information, you have defined outcomes that you've established for the physical asset, and you're able to use digital twins to run simulations, interact with your supply chain, use sensor information to make decisions, apply them to the physical asset, observe the outcomes on the asset, and take the learning back to the digital twin. And you're becoming better at outcomes over time, whether it's utilization, decision making, or safety, and this synchronization of outcomes between the digital twin and physical asset helps you consistently become better at operating your physical asset. Now, let's zoom in on the engineering information specifically. You're using various engineering tools to produce design information from various disciplines. When you have a complex project, you don't have information just from one discipline. You have multiple disciplines that you're going to integrate that engineering change in one place. And today, largely, this happens manually. But with digital twin technologies, you can automate all of this integrated engineering change in one place. What we are proposing is to align and establish cohesive information and create a change ledger of all of that information in one place. And this can be done through connectors to each one of these tools that we have on the left side. And those connectors are essentially aligning the information, building the change each time you run the connector, and then you're storing a ledger of changes over time. And you take that ledger of change and then you can inspect what is the impact of the change on your physical asset at any given point on the timeline of your engineering information. And then all the stakeholders of this engineering information that's been brought together, the ledger of change, can benefit in operating the physical asset. Now, as we talked about the layers of information, we're proposing and striving to use this reference architecture, a mind map of sorts. Where on the left, you start with the engineering information. You're connecting, aligning all of that information, and bringing all the engineering change in one place. In addition to that, you can bring in all of the reality data at the GIS and terrain data in one place. We can augment it with the asset performance data as well as the IoT data. When we do this, we have the cohesive, comprehensive digital twin information in the iTwin Hub, and we're striving to build all of this within our iTwin technologies now. You can now benefit from all of this cohesive, comprehensive information through iTwin workflows on the right-hand side. Whether you want to do a design review or run a clash detection against it, you're able to use that information and be able to continuously do this through these automated workflows. You don't have to spend any time manually doing this continuously. Once you have automated this with digital twin technologies, you have a pipeline and you can keep repeating these workflows any number of times you want. You can interact with this information with your supply chain, for example, by exporting to IFC. We support that out of the box. If you need other formats, you can use the open source strategy that we're following with iTwin and iTwin platform to build more connectors, to bring more information in, as well as write more types of export. You can even take all of this information that has been cohesively combined, run it through a data pipeline with machine learning algorithms, and get better insights as well. So in a sense, you're not changing any of your engineering tools on the left side. They stay as is. You don't need to change any of the tools you're using, but you're able to plug in these digital twin technologies, automate the workflows, and you're able to continuously benefit from these digital twin technologies, resulting in essentially integrated engineering change-based solutions. Now, here's an example architecture of what we've done with Microsoft Azure Digital Twins and the iTwin platform. I'll be showing a demo of this as well soon. Azure Digital Twins is basically an IoT platform, and it lets you define a digital representation of your sensors, among other things. What we're showing at the bottom of this picture is basically you have all of your engineering information. You're bringing it all in through connectors. You're able to build up a change ledger, so to speak, in iTwin Hub for the engineering information. You're able to augment it with other information like reality data or terrain information or just background maps. and then bring it to the iTwin viewer. In addition to that, you're able to bring in all of the sensor information through Azure Digital Twins. And we're now able to populate the Azure Digital Twins digital twin definition language, which basically helps you define the sensors, their locations, and the data that's coming from the align schema that we've done through the connectors. Helps us to automatically populate that, so you don't have to go redefine where all of your sensors are laid out in your physical asset in the digital twin ones, and in the iTwin again. We can automatically populate because of the schema we've generated through alignment. And we're able to bring it all in together in the iTwin viewer, and then the various personas are able to leverage this information that's been brought together comprehensively to essentially take advantage of improving the performance or utilization, or just knowing where you are today with your physical asset. Now, speaking specifically of the connectors themselves, we of course support all of the Bentley design information that's being generated. We also support third-party design engineering information as well. In terms of interchange formats, we specifically zoom in on the IFC connector. We support IFC and bringing in information through IFC into the digital twin and keeping it up to date consistently. We constantly add more and more connectors, but if there are connectors that we haven't added yet, because of our open source strategy, you can add your own connectors as well. You don't have to wait for us. This lets you avoid lock-ins, so to speak, vendor lock-ins, so to speak, and still take advantage of the digital twin technologies for your needs. Now, in this connected highway demonstrator, what we have is terrain information, a long stretch of roadway design that includes bridges, tunnels, and roadways with lanes, and a lot of the IoT sensors hooked up to through Azure Digital Twins. This is a very long section of road in Australia, and we're able to now visualize what's happening to the bridge, for example. What is the load and vibration on the bridge, and be able to color code based on the parameters you've specified on the physical characteristics, the load of the bridge. It just turned green, that means it's safe. The yellow was it's going through a warning zone of how much load and vibration that bridge could take. In addition to that, it has sensors in the tunnel. It can count traffic, it's got the camera sensors, it can measure temperature, and you can get alerted to things like carbon dioxide or carbon monoxide or nitrogen dioxide levels within the tunnel. And then using the traffic count as well as other sensors, you can make sense of what's happening within the highway, the long stretch of infrastructure, and take advantage of the digital twin technologies for better outcomes. Maybe you'll end up diverting traffic to avoid this tunnel. In this case, we've collaborated with University of Cambridge and CDPB to build a connected digital twin demonstrator. In this case, we have some reality data information of drone capture that's been it created a reality mesh of the University of Cambridge campus, and now we're zooming into a specific control center over there, and using machine learning technologies we're able to now identify equipment within this reality data. In addition to identifying the equipment itself, we're able to link the equipment to its sensor information, the real-time information of what is happening with that equipment as well. And you can get a live view of that information, as well as get alerted to any changes that are happening, be able to find the specifications for specific equipment, and then manage your facility at the end of the day comprehensively as well. Now looking at another example here of cell phone towers, as the world is going through an explosion of 5G adoption, there's a lot of demand in this area to improve safety and also improve the time to market for this technology. In this case, what digital twin technology software can enable you to do is, capture drone information, create a mesh, align it with your design information that you have, overlay them together as layers, and then you're able to produce reports of what is happening and the capacity of the tower itself. You can do virtual inspections without having a human climb up and face safety issues, and it is very expensive to do this, I'm told, every time somebody has to climb up there. But now you can minimize the number of times a human has to go up there in terms of inspections, but you can also get a better view of how much utilization you have on a tower as well. So those are compelling stories. In this example, we're going to talk about Microsoft's campus in Singapore, where they have where we partnered with Microsoft to map out all of the floors they occupy in a building in Singapore, and then be able to visualize and get a view of a specific floor and get an understanding of the energy consumption within that floor and color code it. You can also do occupancy analysis as well this way, but in this case, you have an open window that's causing your energy consumption to go up significantly, and you're able to get a live alert of this and understand where that's happening, and you're able to better utilize your capacity floor as well as minimize your energy footprint at the end of the day. Now, in this example, we'll look at how you can apply digital twin technologies at the city scale, where you have information about the whole city. Then you're able to get better information to your residents of the city when you're adding new expansions to the city. You can publish all of this information to your residents, get feedback from them. You can do analysis. You can present information of sections of your city as well, city, district, whatever you choose to be. You can provide transportation view of your city as well. So you can provide various levels of information to your citizens within your campus and the outcomes you want to achieve with it. Here's an example where VGIS has used iTwin technologies to create an augmented reality application. This is based on our open and open source technologies, essentially. In this case, they're overlaying some utilities and subsurface information in an iPad application, and they're able to real-time view on a street corner of what is the utility information they are able to see, and this is going to help workers understand what is it that they're dealing with. In addition to that, we have integrated with some third-party applications like SafetyBase. It's an open source identification, management, and communication of health and safety standards application that's based on SharePoint. And this has been integrated with our open and open source iTwin platform, where you're able to visualize all of your health and safety hazards in one place, and you're able to create them, visualize them, point it, and interact with the model, and actually know which elements are causing hazardous situations or safety situations in some cases, and you're able to display all of this information in one place. This is another example of having two forms of technologies coming together to form one comprehensive digital twin solution. Now, with that said, I'd like to conclude by inviting you to join our virtual developer conference for iTwins on November 4th and 5th for you to learn more about what you can accomplish with digital twin technologies and iTwin platform. Thank you very much, and I'd like to take questions if you have any.
Thank you, Pavan. That was fantastic, very insightful, and looking to the audience to submit questions in the Q&A panel. If you have any questions, we will endeavour to get there. So I had a question actually myself for you watching your presentation. Just checking your audio, Pavan.
Yep, I'm here.
Great.
Thanks.
I see your approach to open source is essentially a fundamental part of your strategy. How do you feel this will contribute to enabling some kind of ecosystem by where lots of businesses in the community can interact very easily with Bentley applications?
Yeah, we absolutely hope that would be the case, Aidan. Good question. So as you saw in one of those demonstrations on what we did with Azure Digital Twins, where it's a separate technology primarily catering to the IoT information that people bring along, and we're bringing the rest of the information, like the engineering information, the reality data that people are capturing into one place and combining it to form a solution. And that's where our open source plays a significant role. We understand we're not going to be able to solve every problem. That's why making it open source and making it easier for the infrastructure community to adopt it for the solutions they need is going to be key.
Fantastic. And I saw that you run that developer workshop. Do you run those open source developer workshops regularly?
Yes, we have webinars now that we're running regularly. Some go deep into the technical details, some talk about what other people are doing or that we're collaborating with other folks in the community. So yes, we plan to continue to do that, and we're happy to engage with others on the problems they're solving.
Thank you. And I see some questions are rolling in now, but I had another one regarding your reality meshes. I'm assuming those captured from photographs or point clouds. Are they engineering ready? So can they be used by engineers for precision and workflows within that?
So it depends on the processing you do. As some of you must be aware, we offer some reality data services to allow you to process that data. And as long as they're high quality images or scans at the end of the day, yeah, we're able to enable that level of precision as necessary.
Fantastic. I have a question here from one of the audience. Which versions of IFC do you support for horizontal infrastructure? And I know that a lot of comments here from Roadway Authority in the US.
Yeah, we support all the various versions that are existing, especially the more ubiquitous version 2.3 and the rest of them. We're also looking at the most current formats, the IFC 4.x as well, and working with Building Smart and the community to support those as well. So we are definitely committed to supporting all the various IFC formats to allow people to interact with our platform.
Fantastic. Another question here about OpenBIM methodologies. OpenBIM is something very close to the Building Smart community's hearts. How does Bentley contribute to the better exchange of data to avoid data lock-in for end users?
Yeah, so we are what we're doing with the iTwin platform and the open source strategy is to align all the information, but at the same time, as I mentioned in my presentation, you are able to extract all of that information using our open source software and take it off to any other format, especially when you're working with your supply chain that's not using these digital twin technologies. You are in charge of that. We're supporting out of the box IFC support, as I mentioned, and we're going to strive to support other formats as our users demand it, but at the same time, they're not locked in. You could take our open source and implement things yourself.
Fantastic. There's a good question here from the audience. Are you considering to implement existing open standards permanently within your packages? And are you aware of some of the latest digital standards such as IFC Bridge?
So yes, we are committed to supporting IFC as a standard and other standards. As I mentioned, we're not looking, as part of helping people adopt the digital twin strategy, we're not asking people to go change the software they're using today. So we are striving to support as many standard connectors as we can. In addition to that, using our open source strategy, the community can implement the connectors that we haven't yet implemented. So in that sense, you can augment what we're providing as a platform rather than wait for us to do everything as well.
Fantastic. It's a good question. What is the main challenge to work with IFC data in order to take advantage of it as best as possible?
So I think the challenge is as with other formats, it's the various versions that exist and supporting all of them. But I think the bigger challenge is producing change. IFC is usually used as a format to exchange information rather than you're natively producing information in that format. So in that sense, understanding what's happening to your engineering data as change is a bit difficult when you're publishing it. It's still not impossible. You can, as long as you have the various timeline of your IFC exports available, we can produce change from that as well.
Great.
Yep.
Another question here about whether MicroStation is available for infrastructure, but I think we can agree that that is available for infrastructure users around the world.
Yep.
Another question here. Do you have any public transportation agencies that are actively using your iTwin services?
Yes, I believe we do, especially in the UK, but at the moment, I'm not sure if I can quote those names.
Sure, we'll follow up on that question.
Sure.
As it comes in. I have another question here. Does your iTwins implement any processes for blockchain, and any thoughts about that?
Not at the moment. Those are things we're certainly considering as we look at our technologies and how things evolve for digital twins. If there are use cases that some of you are interested in, please feel free to reach out to us, and we're happy to work with you to see how we can collaborate.
Great. I have a question about buildings here. So how do you go about classifying inner and outer spaces described within buildings and connect other sources of data from that? I think that's the question.
Okay. So if you've designed a building and it comes with that information, we're certainly bringing all of that information into the digital twin today. But if your design did not categorize any of that information, there are capabilities within iTwin platform that enable you to classify information and essentially augment your source data and add the classification as well as add those external sensors ultimately.
Great.
Yep.
Quite a specific question here, but does your platform support traffic models for traffic simulations?
I'm not sure. I don't know if we do out of the box today, but I suspect the answer would lie in the fact that whether we are connecting to whatever that software is to bring those traffic models in. But if we're able to bridge or connect that information into the digital twin, then we should be able to support the simulations as well.
Great. I have a question here in Spanish, but I won't read that. How easy is it to set up on iTwin Hub? Somebody's asked.
So iTwin Hub is our one-place shop for consuming all of our PaaS services that we offer to help you get started on your digital twin journey quickly. This also includes many of the products we offer on top of our iTwin platform, and it also includes our open source iModel.js and iTwin.js to go along with it. So yeah, it's largely self-service. You can come and try things out if you want to try those things out. If you want to try our open source, all you have to do is go to iModel.js.org and look at our examples and getting started pages on how to use it as well.
Fantastic. A lot of questions on infrastructure here. Another question on how to set up iModel Hub, iTwin services. So I think you mentioned that URL. I think we'll send a follow-up email to more information about the hub. So we get quite a lot of questions about that.
Okay.
I think we're at the end of the questions. Some are coming in. Okay, here's one about data security. Where is the data stored and how secure is it in iTwin?
Yeah, very good question. So today, for most of the PaaS services we offer, we use Azure as a cloud platform at the moment, and we use all the standard Azure techniques to secure your data, whether it's at rest or through transport with HTTPS. So all of that is secure. In addition to that, if you specifically desire a more private cloud solution that offers a limited set of features, we offer that as well, and we're happy to talk to you about how to set that up and get started. But we think the easier option is to use our PaaS solution out of the box.
That's it. Do you use any semantic dictionaries or standards to describe the digital twins within Bentley? Things like the Building Smart Data Dictionary or eClass. That's one of the questions here. Do you integrate with those standards?
So the way we align and bring cohesiveness to all of that data is through something called a BIS schema. We call it the base infrastructure schema that other schemas are built on top of, whether it's construction, building, or others. And because of our open strategy, what you can do is take that and transform into the other standards. That's essentially what we're doing with our export to IFC from the digital twin today. And if you need other standards, we can certainly enable that, or you could do that yourself using iTwin platform and our open APIs.
Fantastic. I think we've come to the end of the questions. There are more rolling in, but we will endeavor to come back to those. And I think I would like to thank you for a wonderful presentation, Pavan, and thank you for answering such varied questions there. And looks like a very exciting time for Bentley and for Building Smart in collaboration. One question, would the slides be available for people on a follow-up email?
We can certainly make them available, yes.
Fantastic. Well, I'd like to thank you, and I'd like to also thank the audience for your attention. And we look forward to seeing you at the next Building Smart webinar.
Yeah, thank you for having me here. Thanks everyone.